Okay, hey, you know what? Back again. I guess it's going to be a little bit of math day today because this is another problem actually that I had mentioned before, and I actually had people asking about again. And just to piss off Caper_26, who doesn't get this problem either, I decided, oh shit, hang on, oh what? Okay, well, sorry about that. I thought I didn't know I had the live feed on there, so apologies. So I want to do a explanation of why this actually is the way it is. It is a little bit confusing because the way it's written, it is a little bit ambiguous. Scott probably points out, yeah, things can be written differently, whether it's made obelisk and a few other things. I will get into that. I'm pretty familiar with this particular problem here. A little housekeeping stuff. I want to put out a shout out to Christian Anarchist because I told him on the next video I'd put a shout out to him, but I really was meaning one of the videos that I do rather than just a hangout video. So I haven't been able to make my own video yet, using like real software, except for like these things. So I guess my last one that I did 0.99 repeating equals 1, even though I did have presentation problems, I realized that I reviewed it, I annotated it, so I at least noted on it that there were some problems. But I do owe Christian Anarchist a shout out. He runs a really good show every so often called was it Coffee and Tea, and he's you subscribe to his channel if you haven't already. So I mean, he's really worth subscribing to. And a couple other people I want to put a shout out to, Red's Rhetoric. Hey, congratulations on your promotion, dude. Dude, you've really earned it. I'm so glad you're in college and you're learning about this engineering stuff. You get to learn all that fun stuff about 0.99 repeating was 1, and all the math stuff we've been talking about, which you already know anyways, but you get to master it, so I guess you can say. So huge congrats on that. So I'm waiting on Jade West, but since she's not here yet, I'm going to go ahead and continue. If I have to change the name later of the title, that's fine. But what we're going to talk about today is this little Facebook meme that went around a while back that was 6 divided by 9, open parentheses, 1 plus 2, close parentheses, and whether it's equal to 9 or 1. Now, the biggest misconception on this problem that I found so far is one, this can be written 2 different ways. It can be written with a little slash, which is the called a solidus, or it can be written with an obelisk, which is what you're familiar with in elementary school. You have a little line, you have a dot above it and below it, your division symbol, your grade school division symbol. That symbol, however, is forbidden to be used in higher maths. It's the industry standards for symbology or ISO, whatever the hell, what is it, Industry Standards Organization. I forget what ISO stands for. But basically, you can't use the obelisk anyways. But they do mean the same thing. Historically, they differ. The obelisk, in historical context, was a typesetting thing where it meant literally a vernaculum or a fraction bar, 1 over something else. It doesn't mean that in modernity. It literally means the same thing as just regular simple division. That's why you see it on a calculator. You see multiplication, and on your it just means to divide. Okay, so there's really no difference whether it's an obelisk or not. Now, way we're going to take this, and I'm going to try to go to my whiteboard and present, and please let me know if this is working this time, because I told you I had presenting issues last time. So I'm going to screen share. Let's see if I can actually get to my whiteboard here. I haven't really played with this whiteboard much. Seems cool, but okay. Can you see that now, Enlightened?
Yes, I can.
Okay. And by the way, hey, another shout out to you, by the way. You really did a good job moderating my debate. I don't think I gave you enough props for that, but I'm going to be moderating. Oh, let's throw this out there. I'm going to be moderating a debate. I know we're house cleaning at the moment. Getting all this admin shit out before I do this. There's going to be a debate, it seems, between Max Hangs Out and our favorite Josiah McClain, JoJo. So I don't even know really what the subject's about. It's something to do with whether the Catholic Church or the apostolic or evangelical or something. Which one has more salvational issues? I don't know. I haven't got really the details on it. I'm just going to be timekeeping and make sure that they don't talk over each other. But anyways, he asked me to moderate it, so I said fine. Fun for the entire family. But anyways, let's get into this problem real quick. The way this is going to be 6 divided by 2. Okay, parentheses. This is called a parenthetical group. 2. Okay, this right here is called an expression. And the only difference between an expression and a equation is this right here, an equal sign. That's it. Okay, So this is called an equation. Without this is an expression. They do the same thing. The rules are the same way. Okay, and most people learn these rules in grade school. And they use something called PEMDAS. P-E-M. Oh man, this is really hard to do. This is harder than I thought with this whiteboard. PEMDAS. Okay. Now you could learn it if you're Canadian or English. You probably learned it as BODMAS, BIDMAS, BEDMAS, PPM, DAS, MDAS. There's a lot of acronyms. They all mean the same thing. It literally just means how do we do orders of operations systematically throughout the world. And these are the same things all over the place. There are a few things that do differ. If you allow for exceptions, then you can have what's called implicit multiplication by juxtaposition. That's where the main problem comes into, and that's used in some maths. That's fine to use it, and I'll explain the differences as we go here. So the way we work this problem is pretty simple. We do the P first, okay? And the P means parentheses. It only means what's inside here, what's inside these brackets, whether it be this kind of parenthetical group, okay, or it be a bracket group. While these things do mean certain things differently in different maths, for when it's doing a grouping symbol, these mean the same thing. They are a little different, these little squiggly things like this. Okay. These are used more for sets. But anyways, for grouping, these really are actually the same thing. So we're going to do the parenthetical group first. So what we have is 6 divided by 2. And we work the inside of this first, and of course 1 plus 2 is 3. Okay, at that point, P in this is done. Okay, we've established all the criteria for P. It's out of the way. It has nothing to do with anything on the outside. Anybody who tells you that P requires you to get rid of the brackets is wrong. Absolutely wrong. P does not tell you to get rid of the brackets. In fact, I can give you instances where it's actually easier to add brackets like this, just because if you want to just really be able to look at the problem and say, okay, how do I simplify this and not mess up? You can add brackets in, as long as you're not changing the orders. That's the key thing. You know, I can't scroll down, but if I have like 4 times 2 plus 4, okay? Multiplication, we're going to see that multiplication comes first, but if I just bracket these, okay, I'm not changing anything. Okay, 4 times 2 is still 8, plus 4 is 12. So if I add a bracket here, I'm not changing any of the order operations, so that's perfectly fine to do, so you have a little bit easier way to read it. But anyways, so the next step is the E. There are no exponentials here. Okay, we're not working with exponents, and if you're from another country, you might know it as I, which is indices, and I think the other one is, I can't remember. But anyways, we're not working with any exponentials. Now, here's the tricky part. M in D is multiplication, division. However, these are in the order they appear in the equation of the expression. They're read left to right. Multiplication does not have a higher priority over division, nor does division have a higher priority over multiplication. They are equivalent inverse functions of each other. Okay? Now, you can take any multiplication and make a division, and vice versa. This is a property in math, actually. So these two things, it could be just as easy, PM, DMAS, and actually these are as well. So what we do is we say, what comes first here? Well, obviously we have a division symbol first, okay? This is called a binary operator. Technically, what's called a partial binary operator, but it's a binary operator. So we did this part first, okay? We don't go to the next operator, which is actually a little multiplication thing here that you're not seeing. This is called implicit multiplication. And I'll explain the difference here in a few. But anyways, you have 6 divided by 2 is 3. And then I have times 3, which of course is equal to 9. Okay, because the next thing you're going to do is your multiplication. So you did the division, and then you did multiplication. A and S, addition and subtraction, are not relevant because we don't have any. So again, this equals 9 using PEMDAS. A couple things. People say, well, yeah, but you can use a different method to get to 1. And I will explain that. That is true. If somebody uses a different convention, then they can solve for 1. But we're not talking about that. We're talking about how does PEMDAS solve? How does order of operations solve it? It solves for 9. And the difference is, are you hanging in there, Enlightened?
Yes, I am. And
Awesome.
you erased the whole thing. Hold on.
Oh, sorry. I went in there. Why? Did you
Oh
want
no,
to
no,
talk
it's all
about?
right, it's all right. Because well, I was gonna say I've learned this stuff in high school and middle school. The thing is, when people don't seem to realize that when it comes to division, another way to write it is not the forward slash. We're always taught to write it from the very beginning, an L turned on its side, and the number that you want to divide into goes inside the L, and the number you want to and the other number goes outside the L. So another way to look at it would be you had the part where it says 6 divided by 2 times 3. We already did the parenthetical.
Mm-hmm. And
And instead of writing it like that, instead I wish I could screen share my thing right now. You can take it so that that entire bracket, instead of a forward slash, you can turn it into that little L turn on its side that we were taught growing up. That's how a division symbol looks like.
oh, I got you. I got you. Yeah. Okay. You're talking about like this.
Yeah, like that. Yeah.
Okay. Actually, it'd be the other way around. Two. I'm sorry. It's actually gonna be two. Well, I haven't been to grade school in a while. Two goes into six. Then you can say three. Well, but hang on. Let me erase that.
I would say that. Well, I mean, well, yeah, it would be like 2 divided by 6. But what you did the first time around was correct because you still have to include the parenthetical in it. So
Okay.
so 2 times 3, and then the 6 goes on the outside. Then the problem would continue.
Okay, so let's talk about this real quick. When you have your division, some people might see it written like this, and this is why it's the same thing. Oh, I actually like the bigger thing better here. So dang it, 1 plus 2. These are the exact same thing. There's no difference between the top and bottom here. Now, somebody can make the argument that 100 years ago these were different. Fine, I grant that. This obelisk thing here, right, literally meant at the time, because of typesetting reasons, that this number was meant to be correspond to this number, and this number was meant to be this number. And this acts as what's called a vertical or horizontal bar. And a horizontal bar is anything under this bar is divided into this. This is not a horizontal bar. This is a solidus. This does not mean a vinculum, which means everything under here. Okay, it doesn't mean that. Oh shit, I just messed it up bad. But this does not mean divide all this into this. It does not mean that. So let me go back here. So when we have this again, one of the things that is often brought up is the ambiguity of this problem. And there is a little bit of ambiguity, I will admit that. And the ambiguity is, what convention do we use? Do we use order of operations, which is your default? Yeah, if you're not given anything else, that is basically what you go by. There is another convention, however, that gives what's called implicit multiplication by juxtaposition, a higher order than explicit multiplication and also division. And all that means is when you have two things like this that are juxtaposed, this next to this, okay, that's meant to be done first. It has a higher priority, okay, higher attachment. So this would literally read, after you do the parenthetical group, okay, if we use that convention, this would read like this, in which case it solves for 1. Now, unless you're told to use implicit multiplication by juxtaposition, you shouldn't really be using it. There are reasons in algebra, and in many algebra classes, you will use that convention. Many calculators will use that convention. It's mostly because it's easier to input the formula that way. Because if I have, let's say I want to know x times y times z. Well, I mean, yeah, we all know that this means x times y times z. However, there might be times that this might be one variable, x, y, z variable. Okay, so you don't want to have the implicit because you don't know if this is a single variable. So what calculators do in computational programs is they don't give implicit multiplication any difference than explicit. This literally is the same thing as saying x times y is the same thing as y times x. And by the way, these are all the same symbols. So this little dot means multiplied. This means multiplied, but this can get confused with this variable, so we don't use that. They mean the same thing. So if you do use implicit multiplication, then yes, you would say that by implicit multiplication, this is equal to 1. But again, we're not using that. We're demonstrating that using order of operations, PEMDAS, 6 divided by 9, parentheses, 1 plus 2 is equal to 1. And then I'm going to get a little more technical here in a second if we can. But Enlightened, you got anything to add so far?
Well, I was going to say Well,
Let's
yeah,
see.
x times y times z. Oh, you cleared it. I
I'm
was going
sorry.
to say, yeah.
I'm just,
No, no, no,
go ahead.
no. Sorry, sorry. X times y times z. It would work no matter which order you put them in. I believe due to the associative property, if I'm getting that
Yes.
correctly.
Yeah. Well, yeah. If you yeah, if you have x times y times z, you can say y times x times y times z times x, or z times x times y. You can arrange those any way you want. It doesn't matter the order that you have them in, by any means. That's correct.
Yeah, I believe the meme that you're talking about, yeah, it arose from the fact that the Google calculator, which I'm guessing people derived it from, it follows a certain precedence of rules. It starts with the terms of parentheses, then it goes to exponents and roots, then it goes to multiplication and division, which you said it really doesn't matter which order they go in, followed by addition and subtraction, and ultimately it follows a left to right evaluation of for operators of equal precedence. That's why Google calculator thinks, oh, 6 divided by 2 parentheses 1 plus 2 equals 9, when really it should be 1.
Well, it's actually here. Okay, what you're referring to is this. It's the same thing as Google uses the same thing. 6 divided by 2, 1 plus 2 is equal to 9. What it's doing here is all it's doing is actually showing the multiplication symbol rather than the implicit multiplication symbol. This is your implicit. This is your explicit. These two things are exactly the same thing. This is explicitly showing the multiplication symbol. So therefore, this symbol, the way Google and the Yahoo do it, is correct. This is actually correct. This is just saying that it's 9. It does parse it differently, obviously. It parses it because it puts in specifically the operator here, the binary operator X. The reason it does that because it does follow the rules of operation, the order of operations. Again, there are exceptions called the implicit multiplication by juxtaposition having a higher order, but that's only in certain circumstances when you're in a class when they say we're going to use this different convention. And the way I really kind of express this to people. Let me see. Can you see my whiteboard again?
Yes, I can.
Okay. Let me express it this way. If I asked you to solve this problem here, okay, if I say 1 plus 1 equals, okay, you're more likely to say 2, correct? Makes
Yes.
sense. Okay. Now, if I say 1 plus 1 equals 10, am I right or wrong?
Well, that depends on what base operation you're using, but yes.
Exactly. Bingo. Yeah, of course. So if I'm in base 2, then this is actually correct. This is actually correct here. But did I tell you to use both base 2? Did I give you an indication to use base 2? No. I mean, if you have 1 plus 1, but I think it's called Markiness. I think the correct terminology, that you're assuming that you're in the decimal system. You're assuming that it's base 10. You have these assumptions that if you're working with regular mathematics and there's no indication to give you a different base, then 1 plus 1 equals 2. So yeah, this is not technically wrong if you're using another base. But if you're not, then it is incorrect. The problem with 6 divided by 2, 1 plus 2, is 9 using something like this, but in a different system. If I was giving it to you using a different level of priority, then yes, it will solve for 1. But that's not the way you would normally solve it. If in California, the Common Core that's been enacted is teaching children that 6 divided by 2, 1 plus 2 would equal to 9. So if your kids are in school and they're learning basic mathematics and they have this, the expected answer in the California school system, I'm not going to say for any other school system because I just know California because I've lived there because my daughter goes to school here, and I've talked to her teachers. This is how they want it solved. Okay, so I don't care what Caper underscore thinks he knows or anybody else. Every mathematician I know that I've ever talked to, everybody that has a PhD, every school teacher I know, this is how it's taught in California. Period. If your student puts it as 1, they're probably going to get it wrong because of the same reasons I've given you, that they are expected to use order of operations, not this implicit multiplication. But
Could you go back to the calculator for a second?
yes,
Yes, I was going to say, yeah, the reason why they call it 9 in the calculator is because the little x in between the parentheses and the division treats it as two separate entities. That's where the calculator gets it wrong.
no, the calculator is not wrong. This is not wrong. Why is the calculator
Well,
wrong?
well, you said it. Well, you said in another instance it would equal 1 based on the order of operations that
Well,
you described it.
no, it would equal 1 if, okay. See how up here there's no multiplication sign.
Yeah.
Okay,
So
there is
so then
there,
why? So
yeah. Let me explain it this way. Let me go back to my little whiteboard. Okay, so I'm gonna
Yeah, but your little whiteboard, it doesn't have the X symbol in between it.
Right, but let me show you why. Now, if I have implicit multiplication, okay, I'm going to simplify this. I'm going to say 6 divided by 2, and I'm going to simplify this to 3. Okay. Okay. You see, at this point, using standard operations, division looks, I mean, it comes first. You can see that it comes first. So you have 3 here, right? Times 3 equals 9. You grant that, right?
Yes.
Okay. Now, just by adding a multiplication sign, just by rewriting this explicitly with the multiplication symbol, will change how it solves. It can't. The only thing that can change an expression or equation is a parenthetical group. A parenthetical will change. That's what it does. It changes the order of operations. That's what these things do. So just by showing the multiplication symbol, if this solves for 9, this must also solve for 9. Okay? It's
Oh,
the
hold on,
same
hold on,
thing.
hold on, hold on, hold on. Oh, no, wait a second. I think I retract that because, like, I was always taught with division that, like, anything, because you want to treat it like, it's like a fraction, isn't it? Like, you treat it like a fraction, but, like, turned on its side with, it's the one in the middle.
This right here?
Yes, the one in the
Yes.
middle is everything on that side of the forward slash is a separate entity. So 2 times
No.
3 is 6. 6
No.
divided by 6 is 1. What?
The problem that's not true. The problem is this right here only operates to the next binary operator. Once you reach this right here, this is not included under here. This is right here is the exact same thing, and I'll prove it to you in a second here. Okay, so this right here, these
Okay.
are equal, and I'm gonna go, what we're gonna do is we're gonna go to actually Wolfram Map of Google, actually, because I like Google, and then we're gonna go to Wolfram Alpha. So where is Jade? Okay, so we're going to type in 6 divided by 2. 3 equals 6 divided by 2 times 3. By the way, asterisk is the same thing as a multiplication sign. Okay, lo and behold, result true. These things are absolutely equivalent. You cannot change how an expression or equation solves just by explicitly showing the binary operator. It just cannot be done. So if this right here is equal to 9, this must also equal to 9. And of course, Wolfram Alpha says it's true because of that. Does that make
Okay,
sense?
back to the whiteboard.
Back to the whiteboard.
Yes. So the middle operation is you should treat it as if the parentheses were invisible around the 6 divided by 2.
It doesn't matter. I mean, remember I told you before, it's completely fine to add brackets and parentheses as long as you're trying to, you're not changing anything. As long if you're just showing for your own edification, you can add it. This right here, okay, it's the same as this. The only difference is I've actually explicitly shown the brackets. It's the same thing.
Okay, so if I wanted it to equal 1, I would have to override the equal left-right precedence of multiplication and division. I'd have to include an extra set of
Yes.
parentheses.
Yes, exactly. You actually would have to do this.
Okay, so that's how it would equal 1.
Yes, this is equal to 1 always.
All right, so go back to Wolfram Alpha and let's try that this time.
Um, okay, so what? So you want me to put that whole thing in there, the brackets?
Yeah, the bracket, then the parentheses. Let's see if that turns
Okay.
out true.
Let's see. 2 divided by 1 plus 2, and I do it parentheses and I do brackets because you could use regular brackets. You can use these types, but the thing is, it's very hard to see sometimes, and so many. If you get into calculus, you can lose the flow very easy. So I use this, and most people do that. If you have the initial bracket, it's going to be this type. Then you use the square bracket, and then I think really technically your next one would be that. Don't quote me on that because I usually reserve these curly brackets just for sets, and I think most mathematicians do as well. So, but I don't think it's technically wrong to use these types of things just for clarification. Or you from here on out, you would actually use just square brackets. Okay, but anyways, neither here nor there. So we put this in there. And, okay, why does it say 9? What do we got wrong here? Oh, I got a division. I'm like, no, it can't be. Can't be. God hates me. Okay, so let's start with the multiplication sign. There we go. So we put that in there, and what do we get? 1.
We get
So
1.
by adding this bracket in here, you're overriding the order of operations. and that's the only way you can do it. But and as they demonstrated with my terrible whiteboard here, that just by adding this explicitly multiplication, and again, this could be asterisk, it could be a dot, it could be an X, but there's a couple problems with some of these. Like dot also means dot product. Like if I say X dot Y, it really could actually mean the dot product of two vectors. And that gets into a problem because if you have like, if these are orthogonal, meaning they're perpendicular to each other, they can equal 0, then you get division by 0. And what happens when you have division by 0? The universe explodes. So
Oh, no,
yeah.
actually, I was going to say that. Actually, you should actually write a 0 because I was taught in math that 0 with a slash through it means no solution provided for it, or there is no solution for it.
That's true, and it also means it's very close to the empty set. So I mean, if you have a set like this, oops, shit, did I just do that? I can't believe I did that. I mean, if I have a curly thing like this, because I'm using set notation here, this right here can also mean empty set, which doesn't mean 0, it just means the set is empty. And an empty set is in all sets. But yeah, so you're right. I just do it for clarification because most of the time if you write this, you know you're dealing with 0 and you're not dealing with an O. But anyways, to continue on with this particular thing, there's one other thing I want to touch on with it. Oh yeah. One of the other things is, and when you get into real analysis, which again, I don't remember much of. I only had a tertiary, understanding of it back in the day. But I do remember enough. If you're going to do what's called, a group, okay, I'm going to define a group as G. And I'm going to say that as an element of G, okay, I'm going to say that X and Y are elements of this group. Okay, so whatever this group is, it doesn't matter. It just means that X and Y belong in this group. And I want to say that X times Y, okay, is also going to be an element in this group that I'm going to call G. Okay, I could write that explicitly the same way as X and Y as an element of G. Okay, no matter how you write this and this, you're never going to find a group in mathematics, in regular real mathematics, real analysis, that is going to have this explicitly defined differently than this. In other words, this type of multiplication here and this type of multiplication here would literally have to be defined differently in real analysis, because they're saying that this right here has a higher priority, meaning that if I have like 2 parentheses 3 and a 6, that these right here bind tighter, and that's where we get into this whole adding the bracket here. It doesn't. These right here bind the same way as this in real analysis. So you're never going to find these things being different. These are just shorthand to writing this. So that's another way to understand that, again, unless you're specifically told, or at least you're in a physics class, or especially physics. Physics, a lot of times, if you have mathematics formulas, you probably will be using implicit multiplication as a higher, or implicit multiplication with juxtaposition as a higher priority, but not always. For example, one of the ones I like to bring up is this. If I say 1 divided by, what is it, 1/2 mv squared, okay? We all recognize this, okay? All of us recognize this as a formula for kinetic energy, okay? This does not say 1 divided by all of this, does it? Enlightened?
No, it doesn't.
Okay. So we know that this solidus does not mean that, because you'll see it written all the time like this, okay? But we know that it literally means 1/2 mv squared. This is just called inline notation, that's all. These have to be equal to the same thing. So you'll see it written this way, you'll see it written this way. This is actually the more proper way to write it. That's the coefficient of 1/2, because it does eliminate all these problems. Because when you write it this way, there's no ambiguity there. But since it's just a well-known equation, you can write it either way, and people are going to know what you're talking about. I've seen it written in literature written as this. So you can't say that everything under here is under this bar, because then we know you'll get the wrong thing. It's a solution for your kinetic energy. So anyways, I think I've touched on it pretty well, as much as I'd like to, for this video. I want to keep it pretty short. I'm sorry Jade Weston is joining us. I'm going to have to make it Enlightened and I explain why 6 divided by 2, 1 plus 2 equals 9. If people still disagree, well, I don't know what to tell you, because You can go to any mathematician that teaches anywhere, and they're going to tell you the same thing. Because I mean, I know PhDs that definitely agree with me. When I first saw this problem, I contacted a friend of mine who actually teaches differential equations and statistics at Cal State Long Beach, and he was actually surprised to find that this was actually a meme, that this was actually a controversy. He's like, no, it has to solve for 9 because it has to maintain the properties of the group. And then you get into ring theory, and it was, people, you hear the term ring theory. Groups are involved in that as well when you're forming a ring in a field and things of that nature. But he was really surprised. He didn't even realize that this was even a controversial thing, because it's not in mathematics. This equation has to equal 9. So, anyways, you got anything else to add to it before I close this one up?
No, actually, well, there was one other thing you mentioned earlier, but you didn't touch on in this video, and it was you were talking about some other a math controversy of some kind in which 0.999 repeating equals 1, or it doesn't equal 1.
It does equal
Whichever
1.
the two.
Yeah, no, I did. I just finished a video on that literally like 30 minutes ago.
Oh, you did? Oh.
Yeah, just before you came in this one, I did a video on that one because I had so many people ask me about that one that I wanted to do a quick video. Now, I had some presentation problems on that video, so anybody who watches it, I did annotate that my presentation didn't screen share, but I got most of it out. It's just screen share at some points, so you should be able to follow along pretty well. If you like these kind of things, let me know. I mean, there's other problems that I like to talk about. I'm pretty good at explaining the Monty Hall problem that people have issue conceptually with. Maybe I might do a video on that. But I'm doing some of these smaller videos just to get away from the regular things that we usually do involving, Young-Earth creationism and flat Earth and all this other stuff we debunk. So I figured math would be good to debunk as well. Go ahead.
Oh, yeah, the Monty Hall problem. I was actually looking into that some time ago, and apparently, from what I read, if you were to take the objective approach to choosing a different door than staying with the same door, then your chances of winning increase, as opposed to if you were to just stay with the same door.
Correct. Yes. A lot of people have a huge misconception of why that actually works. They don't understand it. They literally think that because you have 2 doors, that your probability is going to be weighted equally. That's going to be 50-50, even though it's not. You actually have a 1/3 greater chance of winning if you swap. And I might do a video on that in a few. I don't know if I do it today. It depends on how much time I have. I want to end this one. I'm just going to mute you real quick because of your feedback. And anyways, thanks for joining me on this one, Lightning. Again, very small videos, just to get these things out there and talk about them, because I think we needed a change of pace. So I appreciate the people watching. If you got any suggestions or anything that you want to learn conceptually that maybe I can help with, whether it be math and I don't know, maybe physics a little bit, but basic stuff, nothing too complicated. I'm not going to be able to describe Ricci flow or dark matter and stuff like that. So keep it simple. But if you have these questions you want to know about, I like explaining things. So just send me a message and see what I can do on it. Other than that, I'm going to end this broadcast, and we've decided unequivocally that 6 divided by 2, 1 plus 2 is equal to 9. Why? Works, bitches.